Hey guys, welcome back to another A-Level Maths video. We're continuing with the kind of series where we're going through every single exam paper that's ever come up, going through the examiner's reports, telling you exactly where you get the marks and where people lost marks. So let's just jump straight into the first question. First question, just hopefully a fairly simple standard deviation. Differentiation. I was going to say standard differentiation, I think. So the first way we have to find dy by dx in its simplest form. So again, when you differentiate, you bring the power forward. So that's 4 times 3, which is 12x squared. That would be minus 14x plus 5, because again there's no x that time because x to the power 1 is 1, so you bring the 1 down, you have x to the power 0, which is 1, and then constants just go to 0. And then again we do the exact same thing for part 2, but we're doing d squared y by dx squared, so we differentiate one more time, we get 24x minus 14. And then for part B it says find the exact value of x for when that whole thing equals 0. So 24x minus 14 equals 0. Add 14 to both sides, we get 24x equals 14. And so we get x equals 14 over 24, which you don't have to simplify, but we can if we want to. So like 7 over 12. And we can leave it as that. Not too bad. Here we have a sequences question. So Jamie takes out an interest-free loan of £8,100. He makes a payment every month to pay back the loan. He pays 400 in month 1, 390, 380, and so on, so that the amount repaid each month forms an arithmetic series. Show that Jamie repays £290 in month 12. So all we're doing here is we're going to use the arithmetic series formula, which is going to be a plus n minus 1d, where a is equal to £400, and d is equal to negative 10, right? Because as you can see, it goes down by 10 each time. So it says in month 12, so all we're going to do is we're going to sub in u12 equals 400 plus 12 minus 1 times minus 10. So that'd be minus 110, which is indeed £210, £290 even. Cool. That's only one mark though, sadly. However, it says after Jamie's nth payment, the loan is completely paid back. Show that this expression here. Now it's kind of hard for students to kind of see the link between this sentence and this part of the question. So instead, just focus on the sentence and forget about this until later. After Jamie's nth payment, the loan is completely paid back. So what does that mean? That means in total, he's paid back £8,100. In other words, Sn equals 8,100. And now you can see what we have to do. We're going to use the Sn formula in order to create an equation that will have only n as an unknown. If you remember the Sn formula, it's n over 2, 2a plus n minus 1 d. So now we can just sub in that we have 8,100 equals capital N over 2. 2 times a, that's 2 times 400, which is 800, plus capital N 10, and then I'm assuming if we just expand the brackets and then move everything to one side, we should get an equation that looks like that. I'm going to times both sides by 2 to start with, so that's 16,200 equals 800n, and then from here we're going to get minus 10n plus 10. So if I expand that with this, we have minus 10n squared. And don't forget, I've times everything by 2, right? That's why I'm not including the half in this. And then we get plus 10n. Now if we move everything to one side and then start simplifying, we should be able to get the expression. In fact, we're going to move everything to the left-hand side. So that's 10n squared. That's 810n, so let's write that down. Plus 200 equals 0. And again, looking back at the answer, oh, that would be minus, whoops. That's why you always check the answer, right? Look back at the answer, if I divide this through by 10, I'll get n squared minus 81 plus 1,620. So now we just divide by 10. So n squared minus 81n plus 1,620 equals 0. Nice. Then it says hence find the value of n. So of course that just means we're solving the quadratic, which we can do in a bunch of different ways. You should really factorize it, but let me show you a little trick, right? The reason why I say that is there are parts of questions where they say, you know, solutions based entirely on calculated solutions are not accepted. So let me show you something quickly. We are going to use a calculator. I want to make it so the examiner doesn't know we've used a calculator. So we get n is 45. So I'm going to leave a space quickly. So we get n equals 45. And we get n equals 36. Right. Now, logically speaking, if I wanted to work out the brackets, all I'd have to do is, well, how do you get these answers when you have the brackets? You make the bracket equal to 0. So if I move the 45 to the other side, that means to factorize this, it should be n minus 45, because that's how I get the n equals 45. And then the n minus 36 equals 0. Now, if you think about it, what are the solutions? Well, 36 and 45. If I expand this, n squared minus 45n minus 36n gives me minus 81n. And I'm going to assume 45 times 36 is 1,620 because everything else is correct. Cool. Now the question is, why do we get two answers, right? That's kind of a big question. Well, if we have a look at this, because we're minusing 10 every single time, then there's going to be two values of n where we actually reach the total of 8,100. Because we're going to go past 8,100, then we're going to go back down again. So what do I mean by that? Well, let's sub in n equals 44 into the UN formula, right? So 44. And I'll show you what I mean. Again, it's just because of the structure of the problem. So 44 minus 1. As you can see, I get a negative number. Now, does it make sense that he would pay back a negative amount towards his loan? In fact, not just that. A negative amount means that the person who he took the loan from is paying him. Does that make any sense? No. But that's why we get two solutions for this. Because eventually we pay back the whole loan, right? Then we keep paying back more than the loan. Then they start paying us. So overall, we would have paid 8,100 in total again. That's what this is basically showing us. Whereas if I sub in 36, we'll get just a positive number. So in short, this is our actual solution. And hopefully it makes sense why, right? If you were to plot this, you actually get a quadratic, right? So where this y-axis is the total amount we've paid back, we get a big happy face, where both of them on the right-hand side. And again, we're looking for where we get 0. So yeah, hopefully that makes a bit more sense, but that's also why in the mark scheme they just say n equals 36. That might be a bit confusing to some people. Okay, so a nice little question on graph transformations. So we have a 0.3 minus 2. Remember, this is the x-coordinate and the y-coordinate, lies on the curve y equals f of x, and we just need to find how the coordinates of P change under these different transformations. So again, key thing to remember, if it's inside the bracket, it only affects the x-coordinate and it's lying to you. So it's not telling you the truth. So this x minus 2 means it's affecting only the x-coordinate, so I don't have to care about the y. In fact, I can just put down the y value as minus 2 straight away because I know nothing's happening to it. And it's lying, so we do the opposite. So instead of taking away 2 from x, we're going to add 2 to x, which means it's going to be 5 minus 2. Likewise for the next one. Again, it's inside the bracket, so it only affects y. So let's quickly just write down the y-coordinate again, because nothing happens to it. And it says 2x, so that's 2 times x, but it's lying to you, so we're going to divide x by 2, which is 3 over 2, or 1.5, however you want to look at it. Now the last one's a bit more interesting, because this is where people get a bit confused or a bit scared, because there's 3 different transformations happening. But again, just remember, the one inside the bracket is only affecting x, so do it one at a time. Right? So that minus x, it means times by minus 1. The opposite of timesing by minus 1 is dividing by minus 1, by the way. It's not timesing by 1 or something like that. So what we're going to do is we're going to times x by minus 1, which is minus 3. The other thing that confuses some people is which order do you do the other transformations in? You follow BIDMAS. So for example here, we times y by 3, and then we add 5. So minus 2 times 3 is minus 6, add 5 is minus 1. That's it for 4 marks. Not too bad, to be honest, not bad. That's 4% in the overall paper. Okay, so we have a sequence u1, 2, 3 defined by this recurrence relation that the next term in the sequence is k times the last term in the sequence, take away 5, and we have u1 is equal to 6. Given that u3 is -1, show that this. So we have to use this somehow. Now the only way we can use this is if we also know what u2 is. So let's work out u2 quickly. So u2 is going to be k times u1, so it's going to be 6k minus 5, which means u3, which I already know is equal to -1, is going to be k times all of this, minus 5. Whoa, why am I doing another bracket? Cool. And we know that that equals -1. So let's expand, simplify, do all that fun stuff. Move the 1 over, we get -4 equals 0. And that's it, we're done. Nice. Then it says, hence find the value of k, and then find the sum of the first 3 terms, which is easy enough because once we work out what k is, we can sub in for u2 and u3, bish bash bosh. So again, let's just solve the quadratic using our calculator. We have 6 minus 5 minus 4. So we get k is 4 over 3. And we're going to get another value of k as well, -1/2. Now, it says k is a positive constant, so we immediately know that it's going to be k is 4 over 3. Cool. So we know that u1 equals 6. Yeah. We know that u3 equals -1, and that means u2 is equal to 6 times 4 over 3, which is going to be 8, minus 5, which is 3. Which means the sum of the first 3 terms is just 6 plus 3 minus 1, which is 8. There we go. That was not bad at all. Not too bad so far. Okay, small angle approximations. I'm pretty sure they give you these in the exam or the formula booklet anyway, but if you're watching this in the future, and they might stop doing the formula booklet, so keep that in mind. Given that theta is small and in radians, use the small angle approximations to find the approximate numerical value of this. So remember that tan theta approximates to just theta, which means tan 2 theta will approximate to 2 theta, and cos theta is a bit of a weird one. It approximates to 1 minus theta squared over 2, which means cos 3 theta, like we have here, is going to be, and this is a bit of a weird one, bear in mind that when it's theta squared, it is the whole thing. So this is actually 3 theta squared over 2. Now we have to do is sub that into there. So we have theta times 2 theta over 1 minus 9 theta squared over 2. That gives me 2 theta squared over, so 1 minus 1 is 0, shockingly. And that becomes positive, so 9 theta squared over 2. That would become, so we can cancel that out, and that would become 4 over 9. And that's it, yeah, or 2/3 if you really want to as well. Yeah, so here we have a question with 2 functions. The first function is e to the 4x squared minus 1. Second function is 8 ln x, and we just need to differentiate both of them. Differentiating this, again, you can technically use like a substitution or a chain rule or something like that. But what we really need to remember is that when you have e to the f of x, when you differentiate what's in the power, so what's in the exponent, and then you write the exact same thing again. So if I differentiate that, we get 8x, just 8x. So we get 8x, and then the exact same function again. Perfect. With ln, it's very similar. However, instead, when you have ln f of x, when you differentiate, you have to do the differential over the original. So in this case, it's actually not too bad. It's just going to be 8 times, so differentiate that, it's 1, so it's 1 over x, so it's 8 over x. And that's it. And it says, given that they equal each other at this point x equals alpha, show that alpha satisfies this equation. Well, first things first, we need to make these two things equal to each other. So let's do that. We have 8x e to the 4x squared minus 1 equals 8 over x. I'm going to cancel an 8 from both sides. I'm going to times both sides by x. Yeah, I'm going to times both sides by x. We get x squared e to the 4x squared minus 1. Actually, no, let's do it. Equals 1. Now I'm going to... There's a few things you could do here. So we could have taken an ln before, but I didn't want to. Yeah, I think we can just continue like this. This is totally fine. Yeah, I think there's a bit of a shortcut I could have taken earlier, but we're going to ln both sides now. And then we're going to have to kind of switch stuff around and do all that funky business. It's 1 equals ln1. And I mean, you can probably figure out what ln1 already is anyway. It's 0, so that just goes away. Now, when you have two things times together inside the bracket, you can separate it using the addition rule. X squared. Do I want to separate that yet? Yeah, I'll do it as 1 and then I'll explain in a second. I'm going to separate the second thing by making it a times e to the minus 1 equals 0. That becomes 2 ln x, which is where you get the 2 ln x from here. Separate these two things out. Again, you don't have to show every step like I'm doing, but this is mainly for your benefit. And then let's say add. Yeah. And then when we simplify this, this just becomes 4x squared. That just becomes ln x. That becomes minus 1 equals 0. There you go. Nice and easy. Yeah, I think there might have been a slightly faster way to do the algebra there. But the thing is with the algebra is the only way you'll be able to find the shortcut is if you already kind of know what steps you need to take, which requires a lot of forethought. But we'll see. Then it's just iteration. So what we need to do is sub in, well, first of all, 1. So we have x1 equals 0.6, which means x2, we just sub it in. And I know what they're saying. They're saying find the value of alpha to 4 decimal places. So let me show you what we're going to do. And this is super, super, super easy. Just like we did iteration back in a GCSE, I'm going to sub in, that's meant to be a 6. That doesn't look like a 6, sorry. Equals. Then we're going to do square root 1 minus 2 ln answer over 4. I'm going to press it once and write that to 4 decimal places, which is 0.7109. 109. And then for part 2, all we're going to do, so we want the value of alpha, right? Now the idea is, as I keep pressing equals, this value is going to become more and more accurate. So all I'm going to do is I'm just going to press it like a million times until it stops changing. There you go. And then just write that to 4 decimal places. Technically, you can stop after the first 4 stay the same, but it doesn't really take much longer to just like spam equals over and over and over again. And there you go. That's it. For 3 marks, that last part is actually really, really generous. I'm not going to lie. Like, I actually quite like that. But anyways, question done. Okay, we have a vectors question. Nice. So we have a line passing through A and B, and it gives us the position vectors of both of these. Remember, a position vector is like some point from the origin. So that would be the position vector of A. That would be the position vector of B. The reason why I'm pointing that out is a lot of times when people get a bit stuck on questions, they haven't really labelled the diagram properly or at all, which is, I can see why, but it really does help you visualise what on earth's going on. So 5, 6, and 8. And for the first thing it says find the vector from A to B. So the vector from A to B, well, I don't know the vector from A to B, so I need to go from A to O. So let's do that, A to O, which is just the negative of this. And then I go from O to B, so I add on O to B. So if you remember, if you watch my videos in GCSE, it's the same way that I do GCSE vectors, because nothing much has really changed. So that'd be minus 2 plus 5, which is 3. Then we have minus 3, so it's 3 plus 6 is 9. And then lastly we have minus 5 plus 8 is 3. So 3, 9, 3 for part A. Not bad. Then it says, given that a point P lies on the line such that the distance from A to P is twice the distance from B to P. Find the possible position vectors of P. So first of all, it lies on the line, so it's somewhere along here, but I can actually narrow it down a bit more. You see, it can't actually be on this side of the line, right? Now think about why. Any point on the left of A is going to be closer to A than it is to B, which means the distance from A to P cannot be twice as big as the distance from B to P, right? Because it's always going to be closer to A than it is going to be to B. So it means I know point P for sure lies on the right side of this line over here. So that's the first thing that we want to do. Now, in terms of like which kind of direction and what places it can be, the first thing we notice is, again, A to P is twice B to P. So we can use this to kind of work out what the vector is actually going to be, because the entire line A to P is going to equal... Actually, no, I shouldn't have written it like that. What I should write it as is I should say that A to P is the whole line, but B to P is equal to 2/3 of the whole line. 1/3 of the whole line to P. And yeah, that works. Because if you think about it, the ratio AP to BP is in the ratio of 1 to 2, right? So that means B to P is 2/3 of the whole line, A to P is 1/3 is 1/2 of it. Okay, so we can use this to work out some of the potential vectors. So we want to work out the position vector of P, which means we want to work out O to P. So first of all, if I start from O, there's a few different ways I can get that. I can go from O to B, then B to P, or I can go from O to A, then A to P. So I'm going to start with O to A, then A to P. And we already know what O to A is, so we can just fill that in really quickly. But we don't actually know what A to P is. So how else can we write it? Well, it says A to P is going to be twice B to P, which means it's also going to be twice the distance A to B. Again, if you want to write this out like this part from here to here is twice as big as the distance from there to there. So we're going to do is 2A to B, and A to B works out in the previous part, 3, 9, 3, equals, so 2 times 3 is 6, plus 2 is 8, minus 3 plus 8 is 5, and 5 plus 6 is 11. Cool. Now, as I mentioned before, there are other ways to get there as well. We could go from O to A, O to B and then B to P, and you would get the exact same answer. So here we have some trig, and we're just trying to use identities to show that the left-hand side of the equation is the same as the right-hand side of the identity. So if you were to do this, probably the best way to do it is combine the two fractions, because if you look at the answer, it's not two separate things, right? It's one term. So if we combine these fractions, we will also get closer to one term. So we're going to times the first one by cosec theta plus 1. The second one by cosec theta minus 1. So that becomes cosec theta plus 1 over plus 1. And then plus the kind of the same thing anyway. Cool. So again, when I do these questions, all I'm doing is I'm looking at the answer constantly, seeing if I'm getting closer or further away from it. So now I can combine this into one thing. I'm closer to having this because there's only one term in the answer. So let's add these together. We get 2 cosec theta all over. Now, the denominator is interesting because I can't really change anything about cosec theta minus 1, cosec theta plus 1. So I'm going to expand it and see what happens there. That would give me a cosec squared, which might give me something in the future. Then there'd be minus cosec plus cosec, so that's nothing, minus 1. Okay, cool. In our answers, we have the 2, which is good. We have cosec, which isn't in the answer, so that's interesting. And then we have cosec squared theta minus 1. Now, cosec squared theta minus 1 reminds me of something else, which is the sine squared plus cos squared equals 1. If I divide this through, so cosec is 1 over sine, so if I divide this through by sine squared, I get 1 plus cot squared theta equals cosec squared theta. Which means if I move the 1 over here, this denominator is the same as cot squared. So let's do that. Okay, that might be interesting. 1 over cot squared is the same as tan squared, so we can write this as 2 cosec theta tan squared theta, if you remember rightly. Because again, 1 over cot, so cot is 1 over tan, so tan is 1 over cot. So that's what I've done there. And now I'm very close. We have a tan, so it looks like the cosec and one of the tans is going to cancel to give me sec. So let's see. Let's write this as 2 tan theta, and then cosec I'm going to write as 1 over sine, and tan I'm going to write as sine over cos. I can see here that these two will cancel. That leaves me with 1 over cos, which is sec. So that gives me 2 tan theta sec theta as the question asks. So again, it's all like looking back at the answer continuously to see what we can do. And then we need to solve this exact same equation. If you notice, the left-hand side is very similar to the left-hand side in this. The only difference is instead of theta, they have 2x. So let's just replace it now. So we have 2 tan 2x sec 2x equals, and what was on the right-hand side? Cot 2x sec 2x. Now again, there is a temptation here to simply cancel sec from both sides, but remember, as I showed you in, I think it was the last paper we did, when you cancel, you get rid of some of the solutions as well. So we're not going to cancel, we'd have to factorize instead. So what I can do is, I reckon timesing through by tan would make sense, wouldn't it? I think that would make sense. Or actually, no, I'm going to do something different. I'm going to move this over to the left-hand side. And then because I can cancel out sec, instead what I'm going to do is I'm actually just going to factorize out sec, so I actually get those solutions as well. And that might take me closer to the answer. So now if I factorize out sec, we have 2 tan 2x minus cot 2x equals 0. So one of our solutions is going to be sec 2x equals 0. The other solution is this equaling 0. And this is perfect. Okay, cool. So we have 2 tan 2x minus cot 2x equals 0. If you remember, cot is just tan, right? Is 1 over tan. So if I times through by tan 2x, I'm left with 2 tan squared 2x minus 1, because again, remember, this is just equal to 1 over tan, equals 0. Move the 1 over, okay, cool, yeah, now we've got it somewhere. Tan squared 2x equals a half. So now we're also going to have, so we have this, we have solutions. We also have two solutions here. We have either tan 2x equals minus 1 over root 2, or tan 2x equals 1 over root 2. Now don't forget, we're only doing this between 0 and 90. So if I look at this, this would be 1 over sine equals 0. And you might notice that this actually has no solutions, right? Because bear in mind, you can't divide by something and get 0. So already that doesn't work. But also if we times by sine 2x both sides, we get 1 equals 0. There's no solution. So these are the only two solutions that we're going to be dealing with. So if I move these over, let's just, I mean, we may as well just work them out, right? So 2x equals, make sure you're in degrees mode. And again, we're only looking for things between, well, because we're doing 2x, we're looking between 0 and 180. Because we're going to half it afterwards. So minus 1 over root 2. Negative 35, well, obviously that's not useful to us yet. But we can use this to get other values. And if we do the same thing with this one, this is probably just going to be positive 35, no? Yeah, so the same thing, but positive. Now, if I draw out the graph for both of these, it's the same graph, but anyways. We're going up to 180. So we're going to have that one, asymptote. That one, where these asymptotes are every 180 degrees, starting from 90. And I don't need to really care about 360, but you know what, let's be nice and, that's actually not a bad graph. It's not symmetrical, but it's not bad. So, we're looking for minus 1 over root 2, which is of course going to be in the negative part. We've currently found this value, which is negative 35.26. If I keep going, there is a value that is actually valid in this region, because again, because we're looking at 2x, we're going to be dividing all of our answers by 2, which means we can look for values between 0 and 180, because obviously anything less than 180 when we divide it by 2 is going to be less than 90. So this value also works. Now the way I do is I don't use cast diagram, don't use rules. Instead I use symmetry. Because this graph is symmetrical, going from minus 1 over root 2 to 0 is the same as going from minus 1 over root 2 to 0 here. So this gap is also 35.26. So all I need to do is do 180 minus 35.26. So let's just do that. Ooh. There we are. Which is 144.7. Actually, does it say how many decimal places? 1. Let's say 144.74 then. And I can clearly see that I'm not going to get any... there's no other answers in that region, right? Because the next one is going to be over here, which is bigger than 270. So, now if we do the exact same thing for the... Oh, I'm impressed with myself. With the other side now, the reason why using the rules kind of sucks is because on the other side we have a positive value here. And this is also positive. So we've actually worked out that as 35, right? The next time this happens is actually above 180 degrees. So it'd be 35 plus 180, so that's too big. So our answers, there's only going to be 3 answers in this case. Actually 2 answers, sorry. It's going to be 144.74 divided by 2 and 35.26 divided by 2. So if we just do that, we have 144.74. Let's divide it by 2. We get 72.4 degrees. And if we do 35.26 divided by... we get 17.6. God, I'm horrible. And there we go. So again, I personally like to use the graphs because I don't need to memorize any rules. I don't need to memorize anything. The cast diagram kind of sucks when you have negative values and positive values as well as negative angles. There's a lot of stuff to remember there. The graph is key because you have to know how to draw it anyway, and it's just symmetry. Figure 3 shows the path of a small ball. The ball travels in a vertical plane. It's thrown from this point, height h, cool. And basically they're giving us a quadratic function. Now, modelling with quadratics, linears, etc. is very difficult for some students, or it's a little bit tricky because they make small mistakes. So with a quadratic function, you need to be very, very careful. It's not just x squared plus bx plus c, and sometimes they give you the maximum points, so some people like to use completing the square form, which is a really good idea, but again, remember, in front of the completing the squared bit, there would have to be an a, because you don't know if there's a coefficient in front of the x squared. So here, you would write h equals ax squared plus bx plus c. Now you might correctly say that a would have to be negative because it's a sad face. That's true, but we're just going to get a as a negative number. And now we're going to sub in all of the coordinates that we get. Now the interesting thing about this coordinate here is that when x equals 0, h equals 2. Well, if I sub in x is 0, that goes away, and this goes away, which means we just get 2 equals c. I'm still going to write x equals 0, h equals 2, which means c would have to be 2. And then we also have that at x equals 20, h equals 0.8. So we're going to have 0.8 equals a times 20 squared plus b times 20 plus 2. Perfect. let's sub all that in. So we have 0.8 equals 400a plus 20b plus 2. So move the 2 over, we get minus 1.2 equals 400a plus 20b. Now you might think, okay, there's two unknowns. There must be another equation that we can solve, which is 100% true. There is another equation. If you read through here, there's another line that says the ball reaches its maximum height when x equals 9. So you can either use completing the squared form, or maximum just means when you differentiate, right? So if I differentiate my original equation, we get 2ax plus b. And it says when x equals 9, we get the maximum. So that means when x equals 9, dh by dx equals 0. So in fact, we couldn't use completing the squared form anyway because we don't know what the maximum value is. Although we could work it out, I suppose. So we get 0 equals 9, nope, 18a, because don't forget it's 2 times x, plus b. So now we have a simultaneous equation between these two. You can just use the calculator to solve simultaneous equations, so I'll show you how to do that, because it doesn't say about not using a calculator. Simultaneous equation, number of unknowns is 2, so all you need to do is make sure that x is consistent. So I'm going to say that a is x. So in the first equation we have 400 plus 20y, which is b in this case, equals minus 1.2. And the second equation we have 18 plus 1 equals 0. So that means x, which is a, is negative 3 over 100. And b, which is y, gives us 27 over 50. Do I want it as decimals? It doesn't actually say. So you know what? I'm not going to do it as decimals. So that's 27 over 50. So the final answer to part A is that h equals negative 3 over 100. Notice how we got a negative even without putting it in the original equation. Plus 27 over 50 x plus 2. Where 2 is the starting height. So whoever threw this is 2 meters tall, which is like 6 foot 2, 3, 4? Something like that. So give a limitation of the model. Now the problem with limitations is that it's different for basically every single question. But you just have to think about why this might be tricky. The first thing I've noticed is, does it actually have a limitation on what x can be? It doesn't, which means there is going to be negative heights, for example. But let's see, what else haven't they considered? So they haven't considered like wind resistance, for example, because this is a perfect parabola. It's completely symmetrical. That's very unlikely to have. The ground might not be horizontal. There might be something in the way like trees or buildings. The ball is not likely to travel just vertically. So when you throw something up, depending on what kind of ball this is, if it was like a tennis ball or something, if I throw that straight up, if it's a windy day, it might also go to the left or right. So it's not just going up or down, it's also going left and right. But also just normally, if you throw something, it's unlikely to go straight up and straight back down. So any of those are limitations. Now for part C, it says Chandra is standing directly under the path of the ball where it's 16 meters horizontally, so that means x is 16 meters. She can catch the ball if the ball is less than 2.5 meters above the ground. Use the model. So basically just sub in x equals 16 and see what you get. For those of you wondering about the error carried forward marks, if your model is incorrect, all you have to do is make a correct conclusion. So if you sub in x is 16 to your incorrect equation, you get a mark. And if you make a correct conclusion from that, you get the second mark, okay? So, you know, they're not that annoying when it comes to that. 16 squared plus. I feel like I'm typing so slowly. So we get 2.96 meters. Which means she's unable to catch the ball because it's not less than 2.5 meters. Okay, so we have a little parametric differentiation question. Honestly, this is normally answered fairly well. There's just a few small things I'd like to go through to, you know, figure out, or just to explain anyway. So again, with parametric differentiation, the logic is here, right? We have two equations for x and y, and they're both in terms of t. So if we were to differentiate them, we would get dx by dt and dy by dt. But that doesn't give me how y changes with x, which is the gradient of the function. because we're doing a tangent, we need to know what the gradient is at a certain point. But if you have a look at this, with the key thing with differentiation, the thing that's so amazing is that you can actually treat it just like a normal algebraic fraction. So for example, if I say dy by dt is here, what fraction would I have to multiply by in order to get, well, dy by dx? Well, I'd need the x to be on the bottom, so I'm going to say that it have to be like this. And we want the t to cancel, so it'd be dt by dx, which if you notice is just the reciprocal of this. So all I need to do is differentiate both of these, do the reciprocal of the x one, and times it by y. Nice and easy. So dy by dt is equal to just 0 minus 3t squared, and dx by dt is, so it's the chain rule, so you bring the power forward, differential is in the inside, so that would just be 1, then times by the same thing again, but with 1 less of a power. We might as well just expand that. And that means dy by dx is the same as just minus 3t squared times 1 over 2t plus 6, which is the same as just minus 3t squared over 2t plus 6. Not too bad, right? Now, in order to find the gradient, what do we sub in? The common thing I see is people subbing in the number 4. That's not correct in this case. Instead, we're going to have to sub in, or we're going to have to find out what t is, right? Because dy by dx is in terms of t. So if I look over here, we are going to use x is 4, but we're going to sub it into the equation here to find out what t value would give me that. So square root both sides, we get plus or minus 2. So of the solutions, we have either, if I take this as positive first, we get t equals minus 1, and we get t equals minus 5, right? If it's minus 2, because minus 2 minus 3 is minus 5. Now, if you notice in the range here, the only one that's actually in the range is t is minus 1, so that's the value we're going to use. So sub that into dy by dx. Gives me, I could do this in my head, minus 3 over 4. Excellent. Minus 3 over 4. And we already have a coordinate as well, so if we use y equals mx plus c, we have y equals negative 3 over 4x plus c. Then all we need to do is sub in the coordinates, x is 4 and y is 2. C equals 5, and then we can just write that in. So y equals, now it does say to give it in a very specific format. All we need to do is times through by 4 and move the x to the other side. It is worth showing all of these steps, not just jumping over to the end, because again, you get loads of marks, most of your marks from method marks. Nice. Perfect, okay. So, it says here, the curve C is used to model the profile of a slide at a water park, so that's probably the beginning of it. Units are in meters, with y being the height above water level. Find, according to the model, the greatest height of the slide above the water level. Okay, there's a few things we can do here. We could set dy by dx equals 0, and then find the maximum that way, because we find the t value for the maximum. In fact, that's probably the best way to do it. The alternative is just to look at the equation itself. So if I look at the equation itself, we have 1 minus t cubed, where t is between minus 2 and 1. Now if I make t 1, obviously it's going to be 0, so it's going to be right at the end. But if I make it minus 2, can you see how this whole thing will get bigger? It becomes 9. Now can it get any bigger? Well, if I make it minus 1, we get 1 minus minus 1, which is 2, so that's not bigger. So yeah, the greatest height above the water slide is just 9 meters. If you set this equal to 0, you could then find you could find out like the value from there, but it's probably just far quicker to just look at the domain and just see which one gives us the biggest value, which in this case was t is minus 2. Okay, so question 11, we're working out the area under a curve. The curve is given by 8x squared e to the minus 3x. And yeah, so honestly, the question isn't complex in the sense that you have to do a lot of thinking about it. There's no problem solving here. This is just integrating by parts. But you're going to see in a second, it's integrating by parts twice. How very exciting. And the reason for that is because we have an x squared at the front. Before I do this, I would like to look and see if there's any kind of way I can shorten this, maybe with a substitution or something like that. But honestly, I think integration by parts is the fastest way to do it. So yeah, we might as well just get into it. We're just integrating between 0 and 1. We're integrating 8x squared e to the negative 3x dx. Now again, some students might get a bit scared that you have to do it twice, but it's fine. Like, that's completely legal. Don't worry about it. You want u to be the thing that you're kind of eliminating eventually. So if it's like a polynomial, then you know eventually it's going to be eliminated. So 9 times out of 10, you're going to use that. And the other thing is just going to be dv. It doesn't really make, v prime, e to minus 3x. And when you integrate that, you differentiate what's on the power, so it's minus 3, and you divide by it, so it's minus a third e to the minus 3x. And yeah, so once you have all of your variables, you just have to sub into the formula, which is uv minus uv minus the integral v du. Good lord, that took me a while to get out. So uv minus v du. So u times v is 8x squared minus the integral, again between 0 and 1, of v du. Where's v? Oh, minus the third e to minus 3x du, which is 16x. Fun. Now we have to do the same thing again. By the way, at the very end, we are going to have to sub in for 0 and 1. So this is also getting the, you're also subbing in the 1 and the 0. It's just that I didn't put it here because it's going to be a bit messy otherwise. So here we need to do literally the exact same thing we just did. U is going to be the thing that's cancelling, which is the 16x. You know what? I'm actually going to move this out of here to make that a plus. So then this is now positive. So we're going to get 16 over 3x, which means when we differentiate it, we finally get a constant. And then for v prime, it's going to be the same thing again. It's going to be e to minus 3x. And v is going to be minus a third e to minus 3x once again. Okay, so then this becomes uv, so we get minus 16 over 9 minus, minus 16 over 9 x e to the minus 3x minus the integral of v du. So again, I'm going to make that plus to take the negative out. God, I think I've had a stroke or something. V du, so that's 16 over 3. Text. Finally, which means we can finally integrate this nice and easily. If you just take all the constants out. Actually, no. Let's be chads, right? We don't need to. So again, that's going to be divided by minus 3, so it's minus 16 over 27 e to the minus 3x. Cool. So now let's put this all into our brackets. We have, from the very beginning, 8x squared e to the minus 3x. Then we get plus all of this and this. So we're just going to keep it negative, I guess, and that's fine. Minus 16 over 9 x e to the minus 3x minus 16 over 27 e to the minus 3x, and we're subbing in 1 and 0. Now the bad news is we have to sub in 0 as well, but the good part of that is all of that goes to 0, so that's not too bad. Is there anything else we need to do? No, we just need to sub it in. Okay, so we get 8. In fact, I'm going to keep it in square brackets. No, I'm not. Sub brackets. So 8, because if we sub in 1, we get 1 squared, so that's 8. E to the minus 3 times 1, so that's e to the minus 3. Same thing here, we get minus 16 over 9. E to the minus 3 again. And then minus 16 over 27. E to the minus 3 again. It says here a plus b e to the minus 3. Okay, cool, that's fine. And then we're going to subtract. Well, the only thing that actually has any value is this, because it's e to the 0, which is 1, so minus 16 over 27. Okay, that should be right. That should have an e to the minus 3. That's close. So it looks like the value in the front, is going to be the minus 16 over 27, so the 16 over 27. And then we just need to add all these up, but you know what? I'm not doing GCSE anymore, okay? I'm going to use a calculator. I'm just going to add everything in front of the e to the minus 3. So we get 8. What on earth am I doing? 8 minus 16 over 9 minus 16 over 27. And that should be it? Yes. 152 over 27 e to the minus 3. Is there anything that I've done wrong there? Let's have a look. No, that's fine. Yeah, that's all good. Hang on, UV. That should be a minus 8 over 3. So that should be a minus 8 over 3. So that should be a minus 8 over 3. So I need to change that. Oh, come on, man. Really? Oh, okay, never mind. There you go. That's different. See, that's why you always check your answers, right? Always check your answers. There you go. And 5 marks. I mean, it didn't take me 5 minutes, I don't think. But yeah, that's not the easiest thing in the world. Okay, so first question, partial fractions, absolute classic, lovely. And again, because we have 2 factors in our denominator, that means we're going to have 2 separate fractions. So it's going to be a over v plus b over 25 minus v. And then to solve this again, a really useful trick is timesing through by the denominator on the left. What am I doing? That's v, 25 minus v. So timesing through by that, we get 1 equals, now here the v's will cancel, so we're left with just a 25 minus v plus b times v. And now all we need to do is sub in some values of v, for which we can find out what a and b are. So the first one I'm looking at is probably just b equals 0. No, v, actually, we're using v, aren't we? Is v equals 0. We get 1 equals, the bv goes away. That'll be 25a, which means a is 1 over 25. And the other one that we're going to use is we're going to use v is equal to 25. And we get 1 equals 25v. And we get the exact same thing again, 1 over 25. Not too bad. So let's now write it as actual partial fractions. So as partial fractions, it equals 1 over 25v plus 1 over 25 take away v. Not too bad for 2 marks. Now for part B, they give us that the volume in microliters of a plant cell is, after it's been watered, is modelled by this differential equation. The plant cell has an initial volume of 20 microliters. Okay. Find, according to the model, the time taken in minutes for the volume of the plant to reach 24 microliters. Okay, so in order to find that, we're going to have to find out what v is, which means we are integrating this. We're solving the differential equation. Yay! Yeah, so this is going to be interesting, isn't it? Yeah. Cool. So all we need to do is move the v's to one side, move the t's to the other, just double checking. So if the v's go to the other side, we have 1 over v 25 minus v dv, and we're going to have 1 over 10 dt. Now before we integrate, if you notice, you can't really integrate this without separating it into partial fractions first, wherever the partial fractions were, so I'm going to replace the left-hand side with this, and then we can integrate nice and easily. V plus. Don't worry, I didn't forget it. And now we can just integrate both sides and get something that looks fairly nice. So in order to integrate this, I would actually factorize out the 1 over 25. So we're actually doing 1 over 25 integral of 1 over v, and we're factorizing out 1 over 25 integral of 25 minus v as well. So that would become then 1 over 25 ln v, where this would technically be modulus, plus 1 over 25 ln 25 minus v equals 1 over 10t plus c. And let's have a look. It tells me that the initial volume is 20, so we can use that to work out c, because when t equals 0, what was it? V equals 20, right? Yeah, 20. So we get, okay, so we can solve this. So we get 1 over 25 ln 20 plus 1 over 25 ln 5 equals c. We could combine that. If we add it together, they times, so it'd be ln 100. Yeah, that might be worth doing if we sort that out. Actually, I've just realised this 25 minus v, this actually has to be a minus, because when you differentiate this, you'd get minus 1 over 25 minus v. So we'd actually not get this, we'd get minus 1 over 25 minus v, which means we have to correct that by making this negative as well, because now we get positive. So that's actually something that I spotted just now. Okay, so again, hopefully that makes sense, because technically we're doing, when we do integrating fractions, we're technically doing a reverse chain rule. So we need to differentiate, just double check that we actually get the value at the end. Now we can combine it. That'd be 1 over 25 ln 4 for c. And then what are we actually trying to do? We're trying to work out the time taken to reach 24 microliters. So we're going to sub in v as 24 and then rearrange for t. And it just says to do it in minutes. Is t already in minutes, right? No, t is in hours. Okay, cool. So we don't need an exact value then. That's completely fine. So was it v equals 20? 24. Okay, so if we just sub in v equals 24, we get 1 over 25 ln 24 minus 1 over 25. That'd be ln 1 now, because it's 25 minus 24, equals 1 over 10 t plus 1 over 25 ln 4. And because I'm a genius, all I'm going to do is do this whole thing on the calculator, right? We don't need an exact value, because we're rounding it to the nearest minute anyway. 25, and then we can do ln 24 minus 1 over 25 ln 1. ln 1 is just 0, isn't it? Anyways, then we're going to do minus 1 over 25 ln 4 equals that. Then we're just timesing by 10. So it would take 0.7167 hours So that would be, it says to do it in minutes, so all we need to do now is times it by 60, right? And then we're doing it to the nearest minute. Oh, there we go, 43 minutes. Perfect. Because again, that's in hours. So yeah, just be aware when you're integrating, when it comes to a fraction, you need to double check with the reverse chain rule. I almost made a mistake there. And then it says show that this, and yeah, so that's going to be a bit more fun. Essentially what we have to do here is we have to rearrange for v. So if we look at our equation for v, I'm going to copy this down, just what I actually have. And what was c again? 1 over 25 ln 4. Good lord. This is going to be fun. First thing I'm going to do is I'm going to times everything by 25, just to get rid of something. And I'm also going to combine these two logs. So 25 times a tenth, that'd be 2.5t plus ln 4. And what form are we looking at? Okay. So let's exponentiate both sides now. So this would just straight away go away to v over 25 minus v. That'd be e to 2.5t. Now, because this would be in a power, e to the 2.5t plus ln 4, I can write that again as a product of two exponentials, right? Because when you times two things with the same base, you add the powers. So that would go away to just be 4, so that's just 4e now. Okay. Cool. The next thing we're going to have to do is we're going to have to times this to the other side. Then we have to expand and rearrange because we want v equals, but the problem is we have two lots of v. So it's kind of like how we would do it back in GCSE. Obviously this is harder than GCSE. Where we need to expand and move all the v's to one side. So let's just do that. 100 e to the 2.5t minus 4v e to the 2.5t. I'm going to move the v's to this side. So we get v plus 4v e to the 2.5t equals 100 e to the 2.5t. Factorize a v and then we can divide it over. Yes, we can. Okay. Wonderful. v1 plus 4 e to 2.5t. Divide it over. And now it's just a simple case. I say simple. It's just a case of getting it in the exact form that they want, which is fun. So what have they done? Well, on the top is just a constant, and on the bottom is e to the minus kt. So all they've done is they've actually divided top and bottom by e to the 2.5t. That will get rid of, yeah, that'll do exactly what we want. So 100 e to the 2.5t divided by e to the 2.5t is 100. Remember, as long as you do it to the top and bottom, you can divide by whatever you want. 1 divided by this is going to be e to the minus. And then 4e to 2.5t divided by e to the 2.5t is going to be 4. That was fun. Very fun. Oh, good lord. Alright. Cool. Now it says the model predicts that there is a upper limit L microliters on the volume of the plant cell. Find the value of L, give a reason for your answer. Okay, so what's the maximum this thing here can be? Well, first of all, what you might notice when it comes to exponential functions, if it's to the negative, it means that it's going down, right? So the graph looks like this. Now, t obviously has to be positive, so we're looking at everything to the right of this graph. And it says an upper limit, so the biggest value. If you notice, we don't want to make this 0, because if we make it 0, that actually gives us the lower limit on the value, right? Because that's bigger. As you can see, it's decreasing. If you remember your bounds, if we want this to be as small as humanly possible, because that'll make the overall fraction as big as possible, we want this thing to be as small as humanly possible, which is all the way at the end. So as t goes to, actually I should probably write, what part is this? D, yeah. As t gets bigger and bigger and bigger, e to the minus 2.5t approaches 0. So remember, at the beginning when t equals 0, this whole fraction is as small as it possibly can be because this thing is as big as possible. And when you divide by a bigger number, you get a small number. As we go on, because this thing here gets smaller, this overall fraction gets bigger. Now what happens when this actually equals 0? Well, then we get v is equal to 100 over 4, which is 25, which is the upper limit. Actually, it's milliliters, isn't it? No, it's microliters, so it's a mu L. Again, it means it's never going to reach 25, but it's going to get to 24.9999999 going on forever. That was a fun question. The world human population in billions is modelled by the equation P is equal to AB to the power of T, where A being constants, T is the number of years after 2004. Using the estimated population figures for the years from 2004 and 2007, a graph of log 10p against a t is plotted. These points lie on a roughly straight line with a gradient and an intercept and all that stuff. And we need to estimate the values of a and b. So they've told me it is a straight line graph, which means you're going to have something along the lines of, there's two things we could do. We could literally just change this into a log 10p graph by applying logs to both sides. By the way, if you know what a generic log graph looks like in the sense of an equation, you can also use that to work backwards if you really want to. But I think this might make slightly more sense, dare I say. AB to the power of t. So first thing I'm going to do is separate that. Plus. Remember, because we're just timesing two things. This is going to be our y-intercept, because if you notice, this looks like y equals mx plus c. Then move the t to the front. And by the front, I'm actually not going to do it at the front, because I want it to look like a y equals mx plus c graph. So we get log 10b times t. So here we have y equals mx plus c. Now it says find the values of a and b. Now what does it tell me? It tells me the gradient is 0.0054. Well, what's the gradient of this graph if we look at it as y equals mx plus c? Well, the gradient is log 10b, which means log 10b must be 0.0054. To get rid of the log 10, all we need to do is raise everything to the power of 10. How many significant figures? To 3 decimal places. Okay, so now we just need to shove that into our calculator. 1.0, how many decimal places? 3. 1.0125. Nope, what am I saying? 1.013. Come on, 3 decimal places. Can't I count? Apparently not. Cool. And it says that the intercept, which is log 10a, equals 0.81. Now I know that some of you may have been shown a way where you can just kind of always get it right by just saying, oh, log 10b is always equal to the gradient and log 10a is always equal to the y-intercept. The problem with that is they don't always give you the gradient or the y-intercept. They sometimes just say, oh, when the time is this, log 10p equals this. Or when time is this, p is equal to this. Which means if you don't know how to do the equation, you can't actually solve those questions. That shortcut works for this one specific style of questions. So just please bear that in mind before you start memorizing stuff. Understanding is absolutely key when it comes to A-level maths. That and visualizing. So 6.457. 6.457. 6.457. Very good. Cool. And now it asks us to interpret the value of the constant a and b in this context here. So, when you're looking at an exponential graph, again, try and break it down into what it is. When you have an exponential graph, a is your starting value. So, by the way, when they say interpret it in context, you can't just write initial value, starting value. Not allowed. You have to reference the model. Now, it was a case a few years ago where you could just say, oh, it's the initial population, it's the initial size, it's the initial this. They want you to be more specific. It is, quite literally, the world population in 2004. So I know it sounds similar to initial population or starting population, but again, initial meaning when? In 2004. What population of what? You could say the population of humans, I guess, or you could just say the number of the world population. Now, what about B? B is always your multiplier. So if you notice, this actually kind of looks like compound interest, right? B is always your multiplier. So for example, if B is 1.1, that means every time t goes up by 1, it increases by 10%. 1.1 as a multiplier is 10% increase. If it was 0.9, that's a 10% decrease. So in this case, because it's population every single year, B is 1.013, it means that the world population increases by, god damn, 1.3% every year. That's what it means. B is always a percentage increase or decrease. It's a percentage change. And you need to decide, again, if it's a number less than 1, it's a decrease. Greater than 1, it's an increase. If it was just equal to 1, then you're actually just going to get a flat line anyway. So I doubt that that's going to work. Part C, use the model to estimate the world population in 2030. So a number of years after 2004. So all you need to do is do 2030 minus 2004 if you're unsure. T is 26. And we get P is equal to, it's in billions by the way, so just keep that in mind. So we have A, which is 6.457 times 1.013 to the power of, did I say 24? 26, right? Because it's 2030. Yeah. Yes. So we do that, and we get 9 billion. Let's say 9 billion. And it says for part D, comment on the reliability of the answer to part C. Reliability, not accuracy. I mean, we wouldn't know what the accuracy is anyway because, I mean, I'm making this in 2025. So unless you're watching this in 2030, we don't know how accurate it is. What about reliability? Well, think to your A-level stats. What have we done? We have data from 2004 to 2007. We tried to predict 2030. Unlikely, right? So, is extrapolation beyond the data set, therefore unreliable. And by the way, if this model was actually accurate, then we could just keep increasing like the years and let's see what it's going to be like in the year 2100 or something, right? And it's like, it's not going to increase like that all the time, right? Surely. Second last question, and it's looking pretty spicy because of this second part here, the distinct. I love it. Again, the reason why I love these questions is it's all about visualization, so I like to rub it into people's faces. If you draw stuff out, it makes questions like this super, super easy. But we're getting ahead of ourselves, or I am anyway. It says we want to basically find the corners of center of C and radius. So basically they're just testing if you know how to do completing the square for this. So I'm going to have x squared minus 6x. So I'm moving the x's together. Let's gather the y's together. And I like to space that just a little bit. Again, remember, we're trying to imagine we're in an actual exam. We have to try and minimize the errors that we make. So here, let's do it. We've got x, and then we half the number in front of the just regular term, minus 3 squared plus y plus 7 squared minus 7 squared plus 33 equals 0. And you know what, it's not even risk it. Actually, it's going to be minus 9 minus 49 is minus 58 plus 33 is negative 25. Cool. I'm just going to write negative 25 on the end because I'm worried I'm going to forget it. Plus y plus 7 squared. And then all we have to do is move the 25 over to the other side. So the radius is going to be 5 and the center is 3 minus 7. Right? So just move that over. Cool. A different circle, C2, has a center with coordinates minus 6, minus 8, but the radius is k. Given that they intersect at 2 distinct points, find the range of values for k. Well, as I mentioned, let's draw some stuff out. So, our first circle, in fact, let's draw a big set of axes, and I can make it quite large. Of course, it's not going to be a... Come on, Microsoft, why are you doing this to me, man? That's good enough. 3 and minus 7 would be down here somewhere, and because the radius is 5, it means it's entirely in this quadrant. It's not going to touch the axes. So that's C1. And now for C2, it's minus 6, minus 8, which is, actually, you know what, I'm going to write the coordinates. And again, I'm just going to draw this in red, and you're going to clearly see that they don't intersect, right? Because what we're going to do is we're going to figure out how do we make them intersect. And in fact, just to make this slightly more accurate, I'm even going to move this slightly further down, because technically it's slightly off-center, so it's not a straight line. How do we make it so that they intersect at 2 distinct points? Well, if I make this bigger and bigger and bigger and bigger and bigger, There you go. They start intersecting as soon as they touch each other. So when they touch each other, anything more than that will cause them to intersect. Okay? So that's the first thing I want to say. So all we need to do is work out what the radius of this would have to be. Let's do it in black. What the radius would have to be in order for them to actually just intersect with each other. And to work that out, what I need to do is I need to work out the distance between the two centers and then subtract the radius of this one, where the radius of this one is 5. Right, so we're going to do the distance between both centers, subtract 5, that'll be what the radius of this one would have to be. So first of all, distance between 2 points is not too difficult. It's just the difference in the x coordinates and the difference in the y. So that's 3 minus 6 squared plus 3 minus 8 squared. Whoa, not 3, 7. Minus 7 minus 8 squared. Yeah, minus 7 minus 8 squared. God, that took me a while. So 3 minus 8, that's 9 squared. That's going to be 81. So that's going to be 81 plus 1, 82. So it's going to be square root 82, which I don't think you can break down. There you go. So it means the smallest value, this has to be, bear in mind the smallest value is when they just touch each other. We want it to be bigger than that smallest value. So we want k to be bigger than root 82 minus 5. Okay? Because that way they just touch each other. Now, here's where a lot of students lose marks, and I showed this in the last, if you haven't seen paper 1 of this, you should watch that as well, because again with the modulus we have the same situation. A lot of students would stop here. This is why visualizing is really, really important. If I keep making this bigger and bigger and bigger, look what happens eventually. Do they intersect anymore? No. Right? The idea being that eventually this circle will become so large that it just encompasses the other circle and so they don't intersect. And that will happen when they only intersect once on the other side. So in other words, when we have r plus 5, well, okay, we need to work out what the radius would have to be for this. So the radius of this would just be equal to root 82 minus 5, right, because that's that value of r here, plus another 5, plus another 5 again. So don't forget, root 2 minus 5, add 5 would give us just up to here, but we want another 5 on the other side of that as well. So it's going to be less than root 82 minus 5 plus 5 to bring us to the center of the other circle, so circle 1, plus another 5 to bring us to the edge of the other circle. So our final answer, and again, this is for 5 marks, which in my opinion is actually not that bad, considering if you visualize it, it becomes a hell of a lot easier. But I hope that that makes slightly more sense. Those are our values right there. So again, always make sure that there usually is an upper limit, because otherwise the upper limit is infinite. Can the radius of this be infinite? I don't know. Another one, I'm going to quickly talk about this. It's not this question, but there's another question where it says the range of values for k, and it was still a circle, and you find the maximum value, which is like, let's say k is 5, but there's also a lower limit. K is 0. Because if you have a radius of 0, you don't have a circle anymore. So yes, you can drop marks for not writing 0 less than k less than 5 in that specific question. So remember, the smallest a radius can ever be is 0. It can't be smaller. It can't be equal to 0, right? It has to be bigger than 0. So also keep that in mind if you have a similar question to this. Cool. So we have implicit differentiation, but a harder one this time. There are 2 ways to do this. First things first, you can absolutely expand the brackets if you want to. Just putting that out there. But you do not have to. So, let's see. How would you implicitly differentiate this thing on the left? Well, the first thing you should keep in mind is that this is going to be the chain rule. So when we differentiate this, we bring the power forward, that'll give me 3. Then when we differentiate the x, we get 1, right? 1. Then we've also got to differentiate the y. So remember, when you do chain rule, you bring the power forward, you differentiate what's on the inside. So I brought the power forward, I got 3. Differentiate what's on the inside, I got 1 plus. Now when you differentiate y implicitly, it becomes dy by dx. So it'd be 1 plus dy by dx. And then you have the exact same thing again, but you subtract 1 from the power. So hopefully that's okay. Then doing the other side, this is actually nice and easy. 3x squared differentiated is 6x. Then that'd be minus 3 dy dx. By the way, I have got an implicit differentiation video on my channel in case any of this is confusing, where I go through some of the hardest questions that have ever come up on it. So do look that up. It's literally just called like Maths Made Easy Implicit Differentiation. Definitely have a look at it. And now don't forget, we want an expression for dy by dx. So similar to one of the previous questions, we need to bring all of the dy by dx's to one side. So we have to expand the brackets. I'm not going to expand the quadratic though, because I don't want to. So we're going to have 3x plus y squared plus dy by dx, x plus y squared, equals 6x minus 3 dy dx. Let's move the dy dx to the left-hand side and move this to the other side. We get dy by dx y squared plus 3 dy dx equals 6x minus 3 x plus y squared. Now I can factorize out the dy by dx, which is handy. By the way, just so you know, there's a lot of equivalent expressions to this answer. If you have a look at the mark scheme whenever you get the chance, there's like a million different ways to write this. So if you've done similar steps but you got a slightly different answer, just check if it's one of the equivalent answers, because again, there's so many that you can do for this. And there you go. For 5 marks, I actually think that's pretty reasonable. But with implicit, people always forget about like the dy dx and all of that fun stuff, and they get a bit confused with it. Especially when you have to differentiate something like 3xy, and they get a bit confused there, where it's 3y plus 3x dy dx. That gets a bit confusing. So again, if you need a refresher on that, you know where to find my YouTube videos. So the normal to the equation, the normal to C at point P as the equation this. Okay, cool. So first thing we need to do is we need to sub in x equals 1 into our dy by dx formula. Actually, before we do that, we have to also sub in y equals 0 into that formula as well. Does that cancel anything? No, of course it doesn't, right? That would make my life too easy. But the good news is we don't have to write multiple things, so that's nice. So 6 times 1, I don't know why I'm subbing in the 1, but you know what? 1. Oh, I didn't need to use a calculator for this. What am I? Oh. Mitch is falling off. 3/4. Cool. Yeah, I really didn't need to use a calculator for that at all, did I? Oh well. Wait, is that even correct? Yeah. Did I forget? No, that's all completely fine. Yeah, I don't know why I'm paranoid. So yeah, we get 1/2, which means the gradient of the normal is -2, and so we have y equals -2x plus c. X is 1, y is 0, so we get 0 equals -2 plus c, so c equals 2. Here we go. Y equals -2x plus 2. Perfect. Prove that the normal to c at P does not meet C again. Okay, so when it says that, there's a few ways to do it. One way might well be if I sub it in. Okay, it's not a quadratic, so I can't use the discriminant. Interesting. So the only way to do this is basically solving a simultaneous equation. We're going to sub in for y, and we're going to get probably 3 solutions, but 2 of them won't work. The only one that does work is when x equals 1. Is there any faster way to do that? I don't think so. Let's just shove that in there. Yay! Would it be easy to work out x? No, I don't think so. Yeah, I think this is probably the fastest way. So we have x plus y, where y is -2x plus 2. 2. Expand and simplify. Am I really going to have to expand a freaking cubic? Oh, I don't want to do that. And that would be plus 6x. Minus 6 minus 2 is minus 8. Oh boy. Yeah, we're going to have to expand this. Fantastic. Do I know how to expand? I mean, we could use binomial expansion to expand this. Is that any faster? No idea. Let's have a look. So that'd be x squared minus 2x plus 1 times minus x plus 1. So then that becomes minus x cubed plus x squared minus plus 2x squared minus 2x minus x plus 1. So then that's minus x cubed plus 3x squared minus 3x plus 1 equals all of that. Thank God we have a calculator that can solve it. Let's move everything to the right hand side so we get 4x cubed. Oh, no. Whoa. I misread that for a second there. We get x cubed. Then those two will cancel. That becomes 9x minus 9 equals 0. Yes. Okay. I would probably just... Yeah, I think we're going to have to factorize this, you know that. That's kind of frustrating. Because I'm thinking if we do it by using the calculator to do it, it does say use your algebra for your proof and make your reasoning clear. So, low key, high key, we might need to do... Fantastic. Okay, what would be a factor? Actually, we know what one of the factors is. One of the factors is x is 1, which means this is definitely divisible by x minus 1, right? Praise be to the Omnissiah. Okay, so divide by x, we get x squared. You know what? Before I make a mistake, this is advice I was giving some of my students before. Always fill in the gaps. It's like you're doing long division and stuff, because now we get x squared. It's x cubed minus x squared. That gives me x squared plus 9x minus 9. Gives me plus x. So that gives me x squared minus x. That's 10x minus 9. Gives me plus 10. Yeah, and now it looks like there are no other solutions, right? Thank God. Yeah, because now we just get 1. Yeah, so there's a remainder, which means there are no other solutions in that range. Not bad. Unless, again, I made a mistake. Let's just double check. So then, no other solutions. Again, if you can try and work out how to factorize it as well, but by factorize I mean factorize out the x minus 1. Obviously, you can't factorize the rest because there's no other solutions, right? So because there's no other solutions for x, there must be no other solutions for y as well, because there's no other x coordinate. And of course, one x coordinate has one y coordinate in particular. Yeah, that brings us to the end of the paper. That was a pretty long one. I think that was a lot harder than the paper one, that's for sure. But yeah, if you found it interesting or useful or anything like that, please do consider subscribing. If you want to join my A-level tuition classes, then my email's in the description as well as my website. Other than that, I'll see you in the next one.